Welcome to Module 3 of the MITRE attack course. In this module, we would cover how attackers move from simply getting into actually running their code and securing long-term access. We would look at common execution methods like command line tools and PowerShell, along with persistence techniques, such as scheduled tasks, auto-start programs, and account creation. We would also focus on how to detect these actions using process monitoring, command line logs, and registry or account activity. Learning objectives. By the end of this module, you will be able to 1. Understand how execution and persistence tactics work once an attacker enters a system. 2. Identify common execution techniques used to run malicious code. 3. Recognize key persistence methods attackers rely on to maintain access. 4. Learn practical detection approaches using process, registry, and account logs. Execution and persistence. Once an attacker gains initial access, their next focus is on execution and persistence. Execution involves running malicious code on the system, while persistence ensures they maintain access even after reboots or credential changes. These two tactics provide some of the clearest and most valuable signals for detection engineers. Execution techniques. Execution is basically the point where an attacker runs their own code on a system. They can do this in different ways, but they most often rely on built-in scripting tools, because those blend in easily and don't raise suspicion. Let's look at some of the techniques under this. 1. Command and Scripting Interpreter, T1059. This technique involves the use of native operating system command lines and scripting interfaces to execute commands. The key detection challenge here is distinguishing malicious use from legitimate system administration. Under this we have Windows Command Shell and PowerShell. Windows Command Shell, CMD-exe attackers often use it for basic setup tasks, like downloading extra files or tweaking system settings. A good detection clue is spotting CMD-exe being launched by programs that normally wouldn't spawn it, like Word, a browser, or a PDF reader. PowerShell. PowerShell is a favorite tool for advanced attackers, because it lets them do everything from downloading payloads to running memory-level actions and setting up C2. They often hide their activity using encoded commands or hidden windows. The best way to catch this is through detailed PowerShell logging, which can reveal the full script even when it's obfuscated. 2. Scheduled task or job, T1053 adversaries often leverage native task scheduling utilities to execute their malware or commands at a specific time or recurring interval. This is a common bridge between the execution and persistence tactics. Under this we have scheduled task and scheduled task creation and modification log. Scheduled task. On Windows, this involves using the tasks.exe utility or its underlying COM interfaces. Attackers often name tasks deceptively, e.g., Windows Update Service, System Maintenance, and run them with elevated privileges. Scheduled task creation and modification logs. Windows Event ID 4698-4702 are mandatory. Look for tasks created outside of standard deployment processes, running unusual executables, or executing scripts with suspicious command line parameters. Persistence techniques. Persistence is the primary method for maintaining access across system reboots, user logoffs, and credential changes. Detection engineers must prioritize these techniques, as successful persistence signifies a long-term breach. Let's look at some of the techniques under this. 1. Boot or logon auto-start execution, T1037, T1547. These are the simplest and oldest forms of persistence, abusing built-in mechanisms that automatically run programs upon system start or user login. Under this we have Technique summary. Attackers add their payload to run keys, or the startup folder so it launches automatically. Detection summary: watch for new or modified run-related registry keys, since unexpected changes are usually a strong warning sign. 2. Create account, T1136. Creating or manipulating user accounts ensures the adversary has a backup access path, particularly if their initial compromised account is disabled. Under this we have local account summary. Attackers create a new local user account to maintain access. Hidden account summary. They sometimes hide the account in the registry so it doesn't appear normally. Detection summary. Monitor for unexpected account creation events and registry changes linked to hidden accounts. Monitoring process creation and image loading. The common thread for detecting execution and persistence is high-quality process monitoring data. This data source provides context essential for behavioral analysis. Under this we have the following. 1. Process creation, event ID 1, T1059, execution suspicious parent-child process relationships, e.g., word launching PowerShell. 2. Command line logging T1059.001, PowerShell detect obfuscated or malicious PowerShell commands, ENC, IEX. 3. Registry modification, event ID 1213, T1547.001, persistence unauthorized additions to run keys for auto start. 4. Account creation, event ID 4720, T1136, persistence unexpected new user accounts, especially ORFOWs, or by unusual accounts.
Detection principle, process lineage, always analyze the relationship between processes. A legitimate application, parent, should only launch expected children. When an unusual parent, like a PDF reader, spawns a command shell, command exe, it's a high-priority detection opportunity. Practical, using Sysmon to monitor for persistence techniques. This lab teaches using Sysmon to monitor registry run key persistence, T1547.001. For the full walkthrough, detailed tasks, and sample logs, check the PDF material for this module.
Summary. In this module, we covered execution and persistence, focusing on how adversaries run malicious code after gaining initial access, and maintain their foothold across reboots or logouts. Students learn key execution methods like command shell and PowerShell, persistence techniques using registry run keys, scheduled tasks, and account creation, and how to detect them through process monitoring, command line logging, registry changes, and unusual account activity.